Link aggregation groups, LAGs, combine multiple independent port connections into one strong connection, making things faster and safer. It's like a group of friends forming a team to get things done quickly. The two most common types of LAGs are static and dynamic. Static LAGs are like a team that works together with set roles that don't change. Dynamic LAGs are like a team that knows how to help each other and automatically adjusts connections to make sure everything runs smoothly without being told. People configure dynamic LAGs using the Link Aggregation Control Protocol, LACP. Dynamic LAGs automatically negotiate and dynamically adjust link aggregation between devices. This configuration optimizes network performance, improves fault tolerance, and ensures compatibility between devices from different vendors. If you'd like to configure a static LAG or would like more information about static and dynamic LAGs in general, check out the links in the description. In this episode of Cisco Tech Talk, I'll show you how to configure dynamic LAGs on Cisco Business CBS350 switches. Next. For this example, I'm using two different CBS350 switches. You need to configure all LAG settings the same on both switches to make the dynamic LAG link work. To configure the LAG, navigate to Port Management, Link Aggregation, and then LAG Management. The first selection is for the load balance algorithm. By default, the MAC address option is selected. This option performs the load balancing by the source and destination MAC address received on all packets. I'll leave this option at the default. If you select IP/MAC address instead, load balancing is performed using IP addresses for IP packets and MAC addresses for non-IP packets. Under the LAG Management table, choose LAG 1 and click on Edit. Give the LAG a name and then enable LACP, the IEEE industry standard that allows negotiation between devices of different vendors. Once LACP is enabled, it becomes a dynamic LAG. Then, from the port list, I'll move GE1 and GE2 over to the LAG members column. In this example, I'm using 2 switch ports to form the LAG. However, you may use more. For a dynamic LAG, there can be up to 8 members on this switch. Click Apply and then Close. You may have noticed that the GE1 and GE2 ports are showing under the Standby Member column. This is because the link is not yet connected. Next, it's time to move over to the second switch for configuration of the same settings. On the second CBS350, navigate to Port Management, Link Aggregation, and then LAG Management. For the load balance algorithm, I'll keep MAC address. Choose LAG 1 and click Edit. Enter the LAG name and enable LACP. On this switch, I'll also use ports GE1 and GE2, but these do not have to be the same as the ports on the other switch. Click Apply and then Close. Now GE1 and GE2 are in the Standby Member column and port channel PO1 has been created, but it is down. LAG configurations on both switches are set, so you can connect the cables between the 2 switches. Plug the cables into the ports you selected when configuring the LAG. For this example, that is the GE1 and GE2 ports on both. Once the cables are connected, port channel PO1 shows as up. Refresh this page, and the link state shows as link up for LAG 1. My 2 ports, GE1 and GE2, are now showing as active members. It's important to note that if you create a dynamic LAG with more than 8 ports, LACP will determine the active ports based on the LACP port priority and system priority. Moving back to the first switch that was configured, refresh the page. The LAG shows as up, and my 2 ports, GE1 and GE2, are showing as active members. Great. To save the configurations after a reboot, click the red blinking save icon at the top of the screen. Be sure to save the configuration on the other switch as well. You now have a dynamic leg on your CBS350 switches, helping get tasks done quickly and effectively. As they say, teamwork makes the dream work. Thanks for watching. I'll see you next time.